Hi everyone, I'm Bhargav and today I'll speak about cyber-driven UI and Dream11. Imagine this, you would like to do a small UI change like tweaking title or color change of a button or adding a new sections, right? Instead of deploying it quickly, if you stop into writing the code, testing and releasing it, by the time the update reaches to user, the moment has been passed. We identify this challenge at Dream11 and this triggers us to build custom solutions which is server-driven UI. At Dream11 we solve this problem. Before we discuss what is server-driven UI, it is important to understand how traditional app increments works. So in traditional app increment, UI developer will write a code and create a release field, do a regression for 2-3 days and post this, then submit our app to App Store or Play Store for approval. Post this approval generally takes few days in case of App Store, and post this approval before we increase the adoption. It is important to identify, to assert the stability of this field so that it does not negatively impact the business, and the stability assurance will also take some time. So in general we can say the release process is slow. After all of this, the updates will be available to user and user needs to install this update in this phone, which leads to sort of slower adoptions. So like a slow release process, time taken for asserting the stability, and the slower adoption which limit us to do a faster UI iteration. So this needs a new and scaled solution. We ask ourselves a question: how can we do a faster UI iteration and less dependent on app release and a framework which support heavy experimentation? And the answer is very simple: server-driven UI. In server-driven UI, the framework separate UI and its logic from the rest of the code. This allows us to control and change the UI from the dashboard. So in SDUI, server sends a JSON which represents UI, and this JSON is interpreted by the client and render components correspondingly. So this, because of this mechanism, product manager and developer can define UI and can change looks and feel of the UI from the intuitive web dashboard without releasing an app, without writing a code, and they get quicker adoptions. So the advantage of this SDUI is like you can modify the component, the looks and feel of the UI, you can do the heavy experimentation. Let's look at the capabilities of this framework. Recording of component, updating styles, add or remove new sections, or support overlays. These capabilities can be deployed using a web panel without writing a code or without releasing an app, and they get instant adoptions. Let's understand each of these capabilities using an example in the context of Dream11. Reordering of section. Using this capability, we can change the order of sections. So in this example, the offer and reward sections in the left hand side, it is below the suggested to section. On the right hand side, it is above the suggested to sections. So in general, when product manager identify that certain cohort of users interacts more with certain component, we can change its positioning and making sure that right component always gets prioritized in the screens. So yeah, let's look at the next capabilities. Adding a new sections. This capability is useful when we wanted to upsell or cross-sell some meaningful use cases, or let's say some features are underperforming and we wanted to add a new entry point for this feature. So using this component, we can add a new sections. So in this context, this tattoo component we have completely built on web panel without writing a code. So let's say if we identify that you are a big fan of Jadeja and there is a discount available in our sister company, which is a fan code, we can create this component, nudge you to buy a Jadeja's jersey, and on click of this buy now button, you will be redirected to the fan code website. Next is changing the style. What if a designer would like to do A/B test on the color of the button, or they wanted to try out certain card layout? They can use this capability. What if content writer would like to do A/B experiment on the title of a section? They can use these capabilities. As shown in the screenshot on left hand side, the background of my next browser is black. On right hand side, the background of my next browser is red. Next capability is adding overlay. So using this capability, we can deploy overlays on any screen in the app. So let's say if user has been a big amount, we can wish them congratulations using this overlay, or we can wish them happy new year, we can wish them happy birthday. Likewise things we can do using these overlay capabilities. Next, I hand over Anirudh to discuss the technical implementation of SDUI. Next one.
Hello everyone, I am Anirudh. I am a part of platform team here at Dream11. So today I take you through how and why we built this SDUI framework at our home. So I am sure you guys already have some basic context of what is SDUI, why we need this, especially at scale like Dream11. We have millions of users and most of our users are on low-end devices. So we need that kind of solution that works smoother on low-end devices. So we have evaluated multiple open source solutions, some SaaS-based products, but none of them fit our requirements, and they are not optimized at scale like Dream11. So we need some sort of custom solution that can fit our custom requirements. So we decided to build our SDUI framework in-house. So here are the key principles of our SDUI framework. It's a platform agnostic. You can use this DSL in any platform like Android, iOS, native, React Native Web, etc. So our SDUI basically tailored for scale like Dream11. It smoothly render on low-end devices. Like most of the users are basically have budget devices. So we want that like our UI update goes to each and every devices. So we built this for our custom use case. And third one is we have smart versioning. Like we frequent releases our app, then most of our component dependent on new releases, and some of our component dependent on older versions. So we make this SDUI basically version dependent. So like we need to register our SDUI component on our component registry so that our interpreter can take these components from our component registry and enter on your screen based on your app versions. So now deep dive into our SDUI architecture, how we build this. So what are the core pillars of our SDUI architecture? So first one is our robust DSL. So it's nothing just a JSON structure of our UI. Second one is our interpreter. Basically, interpreter helps us to pass this JSON into React Native components. Third one is our standardized component. So we standardize our component with some sort of structure so that everyone can use their components on each and every screen. They are reusable and efficient enough to render on any screens. And the last one is our render engine. Basically, our render engine takes the JSON, that is our DSL, and pass to the interpreter, and then render this DSL into your mobile screen. So let's discuss one by one. First one is our robust DSL. So it defines basically UI in JSON and enable dynamic update. Let's say if someone wants to change something, on screen from product team, we just need to change the UI hierarchy from our dashboard, and our dashboard will put these changes in our backend, and our app basically fetch these changes via JSON on app launch and render the screen. So basically it decouples the UI structure from the client side. We have fully control from the backend. It ensures real-time updates without any app releases. So we don't need to basically wait for release to change any UI on any screens. But it's just like our screen should be compatible with server-driven UI. So next one is interpreter. It's nothing just a parser that parses the JSON into a React Native component. So, but for this we need to register our SDUI compatible component in our component registry so that they are backward compatible across their app versions. Basically, you just need to make sure your component should be SDUI compatible. So you can register your component here, and our interpreter will take your component from here and render on the screen. Third one is our component structure. So it defines basically reusability and optimized UI components. It reduces the redundant implementation across screen. You can reuse your components at any screen. It ensures consistency and efficient UI rendering. let's say if I want to make any component SUI compatible, this is an example. Here is your regular React Native component. It's basically just rendering a text and wrapped in a pressable. I want to make this component SUI compatible. So what I need to do is, I just change the input props of our component that is configurable prop. It's a type of our SUI. You just need to give this type and your component would be SUI compatible. Rest of the things we will handle automatically. So basically you just need to register your component in our component registry so that our render engine or interpreter can take this component to render. So now we have JSON, we have interpreter, we have basically components. Now the last part is render engine. So it helps us to basically bring the UI into real time. So it converts past UI JSON into React Native components so that they can render on your screen. It handles layouting, styling, interaction automatically. We no need to take care of about anything. Our render engine basically handles all these things. It optimizes basically for faster rendering because we optimized our DSL. Like we decrease the depth of our DSL so that it can render fast on lower devices also. So these are the basically 4 core pillars of our SUI architecture. So as we discussed multiple times, like we build for lower devices. So what we have done is for lower devices. So we optimized our DSL. We built some sort of compact JSON to reduce basically payload size and network bandwidth. And it's basically help us to minimize your UI rendering. You know, your UI will be refreshed, but only that part that you have changed from your backend, not full screen will be refreshed. And the second one is our component variations. So we have multiple types of component. So like first one is business component. Let's say you have some complex components like match card, create team in a web. So you can't make this component SUI compatible directly. You need to pre-bake this in your application. So we have a component variation based on component types. So these are the core elements basically. So you need to just make your component SUI compatible and it will render via render engine automatically. So and the second one is JSON based components. It helps us to basically roll out new component that was not a part of your application. Let's say if you want to render some banner on your screen, so you just need to put some JSON hierarchy in your backend or dashboard. So from JSON, our render engine basically detect the JSON and create some sort of component based on their base components like view, image, etc. etc. And the third one is we have remote server components. Like let's say you have a component, you have a code, you just need to pass this code into your screen. So we have a support like transpile JSX. We can directly create a transpile JSX from the label script, and this transpile JSX we can put in our dashboard. So via backend it will reflect into your application. So we have a special component that is remote server component. It will dynamically update your UI based on already transpiled JSX. We don't need to compile this JSX. And the third one is we have done like performance tuning. So we minimize the UI tree depth for faster rendering. Like let's say we have a nested JSON structure. So like if we can say we have 10 level of nested JSON structure, then rendering might be slow. So we have flattened this JSON hierarchy to render fast. And we have done some sort of efficient state management to reduce memory footprints. So these are the things we have done this so far for lower devices. So basically, so SUI is not only limited to UI, we have server-driven actions also. So let's say you already rendered a component on your screen, but if you want to take some action or interactions when user click or press on your screen, so you can open any URL, you can open any deep link, you can know analytics events, whatever you want, you can do this via our server-driven action. You just need to define the action in our dashboard. Second one is it's highly flexible and extensible. You can swap any existing action with another action. Like let's say there is a deep link binded to your component, so you can swap this action from deep link to direct navigation. So you can do anything with our server-driven actions. You can replace the action. Let's say if you don't want to open anything, you just need to log analytics events. You can fire analytics event also. and it's basically unrestricted. So you can customize your action, you can penalize your action, you can change your action. Your action could be nested, like let's say you want to fire 2 or 3 action on a single click. One is to open the screen, second one is to close the previous screen, and the third one is to load analytics event. You can do this in a parallel manner. And also if you want to wait something, like if you want to wait to execute action first, then want to execute action second, you can wait also. Like you can wait on the basis of the result of action first. Like first action, if first action is succeed, then you can fire different action. If first action is throw some error, then you can fire some different action. So you can customize your action in any way, like whatever you want. So it will not require any app release. It will run out of the box from our dashboard. Yeah, that's all. So like now I'll hand over to Bhargav for a demo.
Till now we have discussed the multi-server-driven UI, its capability like reordering of component, sending a new component from server, right? But lot of time we would like to showcase this component based on some real-time conditions. Like user has done some actions, then only show this component. We call this condition as trigger, and using this platform, you can specify the triggers. When user click on some button, right, we would like to nudge them for the next steps. But depending on that, when this condition met, so this kind of trigger is also supported by this platform. So in this example, the trigger points are when user has created a team, but the next step is joining a contest. When user has created a team but not joined a contest, we would try to nudge him that you have created a team but not joined the contest. So we can use server-level UI along with a lot of triggers. We have deployed these use cases with a lot of big matches and see a huge uplift in terms of important business metrics. So that's all from server-level UI. Any questions you would like to ask?